Hi there, everyone. Good morning, good afternoon, or good night. Whatever time you are watching this. Are you ready for our discussion? But first, let me introduce myself. Hi, my name is Maisel Jane Imeralias from Section STEM 11 YA 17 TVA of Our Lady of Fatima University. Today, we are going to talk about standard normal distribution and normal distribution. Without further delay, let's get started. Standard normal distribution. Standard normal distribution, also called the z-distribution, is a special normal distribution where the mean is 0 and the standard deviation is 1. Any normal distribution can be standardized by converting its values into z-scores. Z-scores tells you how many standard deviation from the mean each value lies. Bell curve. A bell curve is a type of graph that is used to visualize the distribution of a set of chosen values across a specified group that is tend to have central normal values, as a peak with low and high extreme tapering off relatively symmetrically on the either sides. The normal curve doesn't intersect to each other's. The mean, mode, median of normal distribution are equal. The standard normal distribution has a mean of 0 and a standard deviation of 1. Z-score. A z-score describes the position of the score in terms of distance from the mean when measured in standard deviation units. The z-score is positive if the value lies below the mean. It is also known as standard score because it is allow comparison of score on different kinds of variable by standardizing the distribution. A standard normal distribution (SND) is a normal shaped distribution with a mean of 0 and a standard deviation (SD) of 1. Z-table. A z-table, also called the standard normal table in mathematical table, that allows us to know the percentage of value below to the left. A z-score is a standard normal distribution. In case you didn't know what it looked like, I prepared a sample. But how do we use the z-table? In case you don't know how to use the z-table, I prepared a sample on how to use it. For example, find the z-score of the raw score 2.68. In order to know the z-score of it, first get your z-table. Then find or search for the first and second digit on the given raw score in the first column, which is 2.8. And then search for the last digit of which is 2.8, and then search for the last digit of the given raw score on the top row, which is 0.06. The value where they intersect is the final value, which will be 0.4979. So, therefore, 2.86 is equal to 0.4979. Therefore, the raw score 2.86 is equal to 0.4979. Determine the area under the normal curve of the following z-score. Here is the first example. Area from z equals 0 to negative 2.05. The second example is area to left to z equals to 1.88. The last example is area between z equals negative 2.08 to 2.00. The first example says area from z equals 0 to negative 2.05. In order to know the answer, we must use the z-table. Search 2.0 on the first column and then search for 0.05 on the first row. The value where the two intersect is the answer. Therefore, the area from z equals 0 to negative 2.05 is equal to 0.4798. Next examples, it says from 1.88 to the left, which means starting from 1.88 going to the left. First, find the z-score of 1.88 will be 0.4699, and then add it to 0.5000. So 0.4699 plus 0.5000 is equal to 0.9699. Therefore, the area from z equals 1.88 to the left is equal to 0.9699. The reason why we add to 0.5000 is because the value of the half of the bell curve is equal to 0.5000. This is the last example. Area between z equals negative 2.08 to 2.00. To get the area of the bell curve, first search for the z value of negative 2.08 and 2.00. After that, add them together. The sum will be the final answer. Therefore, the area between z equals negative 2.08 to 2.00 is equal to 0.9584. Our next discussion is all about normal distribution. A normal distribution is a probability distribution used to model a phenomena that has a default behavior and cumulative possible deviation from that behavior. Empirical rule. The empirical rule, or the 68, 95, 99.7 rule, tells you where the most of the values lies in the normal distribution. Example, the exam scores of general chemistry class is distributed normally with 200 students. With a mean of 69 and a standard deviation of 9, using the empirical rule, answer the following question. In the first example, the value that we are searching for is the percentage of the class score between 60 and 87. So the percentage in the diagram that is between 60 and 87 are 34%, 34%, and 13.5%. In order to get the answer, add these three together. That will be equal to 81.5. So that will be our final answer. Next is the second example. What is the chance that a pupil chosen at random has an exam score between 42 and 78? Just like a while ago, but now it's between 42 and 78. The corresponding values that included inside 42 and 78 must be added together to get the final answer. So, 2.35% plus 13.5% plus 34% plus 34% is equal to 83.85%. Third example. How many pupils have an exam score between 60 and 78 approximately? The one we are searching for is the approximate number of students that score between 60 and 78. The solution will be like this. First, add the percentage between 60 and 78. So, 34% plus 34% is equal to 68%. To get the approximate number of students, you must multiply 68% to the number of students, which is 200. So, 68% times 200, then the answer should be equal to 136 pupils. Fourth example, how many pupils have an exam score less than 60? We are searching for how many pupils have an exam score less than 60. So from 60 to the left, just like the others, just add the corresponding percentage starting from 60 to the left. It will be 0.15% plus 2.35% plus 13.5% is equal to 16%. Then multiply it to the number of students, which is 200. It will be 16% times 200 is equal to 32 pupils. This is the last example. What percentage of pupil have an exam greater than 87? Percentage of pupil have exam score greater than 87. Just add the percentage starting from 87 to the right. So it will be 2.35% plus 0.15% is equal to 2.5%. Mathematics is not about numbers, computation, equations, or algorithms. It is about understanding. And this is the end of our discussion. Thank you!